Hey, what's going on, guys? Let's do this problem right here. Here this question is asking to find the heat transfer rate, and we have two different situations. The first situation is when we have this 100 degrees Celsius and 0 degrees Celsius connected with two copper bars, what's going to be the heat transfer rate, right? And the second question is asking if one of the bar is copper and other bar is aluminum, what's going to be the heat transfer rate? Now let's see how we can calculate that one. But this is a conduction process, right? So whenever we have conduction process, we use this equation. Q dot is equal to Ka delta T over L, right? Now the question is what's going to happen when we have two copper bars, and this will work if we have one copper bar. And when we have two copper bars, what's going to happen is we are going to have the area that is multiplied by twice. So we are going to have 2A right here. So that's going to be the difference. So this will work when we have same material, 2A delta T, and we are going to have L in the bottom. Now let's plug the values. So we have thermal conductivity for copper that is provided 385 watts per meter Kelvin. So that's what we are going to plug right here, 385 watts per meter Kelvin, and the area is going to be multiplied by 2. We know that area is 0. So let's put them in bracket. So we are going to have 0.001 meter square multiplied by 2, and delta T is going to be temperature difference. Now the original equation is negative, right? So original equation is negative. Since we don't have the negative, we are going to do delta T like this, T1 minus T2. So that's going to be the delta T, because if you have this one negative and if you do T2 minus T1 and if you multiply, you still get a positive answer. So this one, doing this way and keeping this positive and doing other way and keeping negative is both going to be the same thing. Now let's plug the values. T1 is always going to be the highest temperature. So here we have 100 degrees Celsius, that's highest temperature. So that's going to be the T1. 100 minus 100 degrees Celsius minus 0 degrees Celsius, and that's going to give us 100 degrees Celsius. Now here the thing is, degrees Celsius and Kelvin for a temperature difference is going to be equal, like degrees Celsius and Kelvin, because even if you change this one into Kelvin, for example, if you add 273 to both and if you subtract them, you will still get 100. So you can put 100 Kelvin right here because we want this Kelvin to cancel, right? So this unit has to be cancelled. So let's put 100 right here, 100 Kelvin, and in the bottom we are going to have the length of these pipes, that's 1.2 meter, so that's going to be in the denominator, and if you calculate this value you should get 64 watts. Now let's see what will happen if we have one of them copper and one of them aluminum. Now here the equation is going to be different. Now let's put them right here. So I trace this part. So let's calculate Q dot AL comma CU. Now the equation is going to become KCU plus KAL, and others are going to be same thing, A delta T over L, right? The only difference is we are going to add the thermal conductivities. Now let's go ahead and plug the values and see what we get. So thermal conductivity of copper is 385 and thermal conductivity of aluminum is 205 and the area is 0.001 times the temperature difference, 100 degrees Celsius or Kelvin. In the denominator we are going to have 1.2 meter, and if you calculate this one you should get 49 watts, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.